Hi everyone, it's Nicolas, also known as CoolCat VFX. In today's video, we're going to create a smoke puff effect. This type of effect is pretty common, but very useful in video games. It adds weight and power to characters' landing animation. We're going to use Unreal Engine 5.1, and we're going to use its built-in system VFX tool, Niagara. We'll create models inside Unreal Engine, make 3D meshes using Blender, and paint our own textures using Photoshop, play around with Niagara emitters modules, and see how to sync the spawn of our smoke puff effect with the landing animation of Unreal Engine 5 monkey. We got some work ahead, so let's do it! As usual, we start the tutorial by taking some time to have a clear overview of the effect's components. We got a bright flash, multiple dot particles, few straight lines, some smokes billboards, and a shockwave. We start to create our smoke puff effect by making the bright flash component. For that, we'll need a basic alpha blend transparent model, a flash texture, and a Niagara emitter. Let's create our first model. We want a simple model that handles transparency, allows us to control our particles' color and transparency, and smooths the intersection between our particles and 3D objects. Right-click in your content browser and add a material. We will edit it by double-clicking on the material asset in your content browser. In the detail window, set the blend mode to translucent and the shading model to unlit. We don't want our particles to be affected by the lighting of our scene, and it will make our material less heavy performance-wise. We need to reference our texture first. So we'll right-click in the graph panel and search for the texture parameter 2D node. Being a parameter, this node will allow us to reference, if we want, a different texture on each material instances that we'll create later on in this video. We want to control our particles' color and transparency. The node that we need for that is simply called particle color. To control the color of our particle, we'll connect the RGB channel output of the particle color node to the emissive input of the master node. To control the transparency of our particle and our texture, we will multiply the particle color node's alpha output to the RGB output of the texture node. The final step in our materials creation task will be to smooth the intersection between our particles and 3D objects. This will be especially useful when we will use this material for our smoke component later on, since our smoke's particles will be in direct contact with the ground, and we don't want this ugly hard cutting line. And we can use the depth fade node to do just that, by adding the shade node and linking the multiply output to its opacity input. We will add and link a constant property to control the fade distance with a default value of 50, and add a final node called saturate to keep our opacity value between 0 and 1 and thus avoiding any weird opacity artifacts. After we've linked the saturate node's output to the opacity input of the master node, we got our material done. We'll save it and close the material editor window. We can now right-click on our material asset in our content browser window to create a material instance where we'll be able to reference our flash texture that we're going to make. To make this type of texture, you can use softwares like Adobe Photoshop, Krita, or GIMP. In my case, I'm using Adobe Photoshop. After creating a 512 by 512 document, I'll use a simple soft brush. Apply one big stroke at the center of the canvas, and apply a second one, but with a smaller radius at the center of the first big stroke. My texture is done. I can now export it in JPEG on my desktop and import it to Unreal Engine by right-clicking on the content browser, selecting the Import to option, and selecting my JPEG file. After we've imported our texture, we'll be able to assign it to our material instance we've created a minute ago. Open your material instance, tick the texture option in the Global Texture Parameter Values submenu, and search for your bright flash texture. Alright, we made our transparent material, our bright flash texture, and our material instance. We can now start to create our effect. Right-click in your content browser and create a Niagara system. We will create an empty system. After opening our newly created Niagara system, we'll set up our preview window and get rid of this bright environment to replace it with a neutral color. We'll customize our preview window by going to the Window tab and click on Preview Scene Settings. In this window, we'll go to the Environment sub-tab, untick Show Environment, and pick a dark gray color in the Environment color parameter. That's much better. We'll be able to easily perceive our effects with this preview background color. You can then save these changes by adding a profile right there. We'll also deactivate the default auto exposure post-process filter in the preview window by going to the Lid tab, untick Auto, and set the EV100 parameter to 0. That way, we won't have any exposure variations on our rendering camera. Now we can finally start to create our Niagara emitters. We want a simple particle to be spawned at the start of our Niagara particle system with a short lifetime. This is the first element that will add impact to the entire smoke puff effect. In the system overview, we'll right-click and select Add an emitter. By chance, we already got the perfect template for that, the simple sprite bus template. So we'll choose this one. We'll have to tweak some parameters to fit our needs though. First, in the emitter state, in the lifecycle mode parameter, let's select System to sync our emitter's duration and loop values with our global system update controller. In the initialize particle module, we change the lifetime of our particle. With a flash effect, something short like 0.2 seconds should be enough. We'll pick the particle color right there. Feel free to choose any color and opacity value, depending on your preferences and level's color mood. My level being quite bluish, I'll go for warm desaturated orange with a mid-alpha value. Choosing an opposite color to my level will bring contrast to my effect. We can also set the sprite size of a particle right there. It is important here to note that all values that I'll be using during this video are related to my character's size and level's lighting. So feel free to adjust those to fit your needs. In the particle update stage, we'll add a scale sprite size module to help our flash particle to fade by shrinking it while it's losing opacity through the scale colors module. We'll take a smooth frame down curves template, slide the first key to the right, and add a new one at the bottom left of the curve. That way, our particle will quickly grow in size and slowly shrink. Finally, we want our flash to be spawned above our ground level. To do that, we'll add a shape location module in the particle spawn stage. Set the sphere radius to 0 to center the spawn point of our particle, and set the offset mode to default. We'll then add a small value to the z-axis to elevate our spawning point for flash particle. And finally, in the sprite renderer module, in the material slot, we'll change the default material by our encrafted bright flash material. Now we are done with this particle emitter, don't forget to rename it. We'll continue this tutorial video by making those dot particles and straight lines. For that, we'll use the default sprite material, so we won't need to create any material or texture. We'll create those two components with two Niagara emitters in our Niagara system already containing our bright flash particle emitter. We'll start with the dot particle emitter. We want this emitter to spawn once a bunch of particles that are affected by gravity and can collide with our world to make this part of the effect more physically believable. We'll add an emitter in the system overview, next to our flash emitter, and choose an omnidirectional burst template. This template got nearly everything we need and just needs some adjustments. Just like we did with our flash component, we'll go to the emitter state. In the lifecycle mode parameter, we'll select system to sync our emitter's duration and loop values with our global system update controller. In the spawn burst instantaneous module, we'll reduce the number of particles emitted. 100 is way too many. We are aiming for solo effect here. In the initials particle module, we set a decent lifetime range to our dot particles to let them exist long enough that most of them can actually fall to the ground at least once. We then select their color and alpha value and edit the sprite size range to have tiny particles of dirt. In the shape location module, we set the shape primitive to cone and set a higher cone angle value to have a wider emitting angle. In the add velocity module, we set a small speed range with a good minimum value to allow our particles to fly away when emitted. We'll also lower the origin offset on the z-axis to have our particles being pushed from below the origin point of the emitter. In the drag module, we set the drag force to 1 to slow our particles at the end of their lifetime. In the scale sprite size module, we'll set the curve to a simple smooth ramp down template. We want our particles to be stretched by their speed to accentuate the feeling of speed. For that, we'll first go to the sprite renderer and set the alignment parameter value to velocity aligned. And in the particle update, add a scale sprite size by speed module. We'll set all x values to 1 and y value to a high range between something like 2 to 7. To have some particles highly stretched and other not so much. Finally, to make our particles collide with the ground and add that little extra physically based behavior, in the particle update stage, we'll add a collision module. And that's it, we got our little dot particles done. We can now make the straight line particle emitter. We want this emitter to spawn once few stretched particles that won't stay long on screen. This will accentuate the weight of our character landing. This emitter will be quite similar to the one we just made. So we'll duplicate our dirt particle emitter by selecting it and pressing Ctrl+C and Ctrl+V. We'll start by deleting the collision, drag, gravity, scale sprite size, and scale sprite size by speed modules. Now that we got rid of unneeded modules, we'll tweak some values in leftover modules. In the spawn burst instantaneous module, we'll lower the number of particles being emitted. In the initials particle module, we'll drastically lower the lifetime value range. We need it to not last long. Something between 0.1 and 0.2 seconds will do the job just fine. If needed, we can also edit the color and alpha value of these straight lines to make them quite slow. To get our elongated particles, we'll set the sprite size mode to non-uniform and set a high value in the y-axis. We'll then edit our shape location module. In it, we'll lower the cone length and set the cone inner angle to the same value of our cone angle, to have our straight line particles emitted on the border of the cone emitting shape and not inside of its volume. We'll also take the flatten and caps parameter. Then, in the add velocity module, we'll set higher values in the velocity speed parameter and set the offset a bit higher on the z-axis while keeping said value negative to push particles from below and avoid having our particles only moving upward, but a bit on sides too. We'll take the time to rename our emitters. And we got a straight line emitter done. Half of the work is done here. Now, we'll focus on making those smoke billboards. This part of our effect will be quite important and will carry most of the visual identity of our smoke puff effect. We'll need the basic alpha blend transparent material we've made at the beginning of the video, a hand-painted smoke sprite sheet with at least 4 different shapes, and a Niagara emitter. We'll first create a material instance from a transparent material. Don't forget to rename it. Now, we'll get to the texture part. In Photoshop, I create a 512 by 512 document. We'll make a spreadsheet containing 4 different smoke shapes, randomly picked and applied on each particle by our Niagara emitter. If you want, you can make more. In Photoshop, we got a tool that will help us visualize the texture area occupied by each sprite, the grid tool. It can be activated by going to the View menu, Show, and selecting the grid option. To configure the grid tool, go to the Edit menu, Preferences, and click on the White Grid and Slices option. Here, you'll be able to configure and customize the grid tool. I'll personally make a 2x2 spreadsheet, so I'll need my document to be divided in 4 equally sized areas. Now that the grid tool is set up, we can draw our lightning shapes. You can paint simple yet effective smoke shapes by using a soft brush and applying multiple strokes with different sizes to have shape variations at macro and micro level. Remember to keep the visual varied and not too regular by playing around with small, medium, and large shapes. This will naturally get you value variations inside your shapes, with part being darker and other lighter. You can make your smoke shapes softer by blurring them. To do that, duplicate your layer, go to the Filter menu, Blur, and select the Gaussian Blur filter. Then, above the layer we just blurred, select the Screen Blending mode and lower a bit the layer's opacity. And we are good to go. After you've imported your texture in Unreal Engine, don't forget to assign it in the material instance you've made before painting your smoke shapes. Back into our Niagara system, we want our smoke particle emitter to spawn once multiple smoke particles with one out of the 4 smoke shapes we've painted applied onto them. We want these smoke particles to be emitted in a circle, slide on the ground, and fade away at the end of their lifetime. We'll add an emitter in the system overview and select an omnidirectional burst template. Just like we did with our flash component, we'll go to the emitter stage. In the lifecycle mode parameter, we'll select System to sync our emitter's duration and loop values with our global system update controller. We'll start by editing the visual rendering of our smoke particles before tweaking their behavior. In the sprite renderer module, we'll assign our smoke material instance in the material parameter and type the number of columns and lines of our texture spreadsheet in the sub-image size parameter. In my case, it's a 2x2 spreadsheet with 2 columns and 2 lines. This will be important for our next module to be able to correctly read, select, and apply a sprite from our spreadsheet to a particle. This next module we'll add it by pressing the plus icon next to the particle update stage and searching for sub-UV animation. First, let's fix this warning by selecting Sprite Renderer in the Sprite Renderer parameter. We'll then set the sub-UV animation mode to random and set the evaluation type to spawn only. Now, we'll tweak our smoke particles behavior. In the spawn burst instantaneous module, we reduce the numbers of particles emitted, 100 smoke particles being too many for the scale of a simple smoke puff effect. In the initialize particle module, we set a decent lifetime range to our smoke particles to make them the last particles to be alive at the end of our effect. This will create contrast in timing and lifetime compared to the other elements of our effect that won't live that long and avoid having a boring looking effect where all particles die at the same time. We'll choose a fitting color and alpha value and scale up the sprite sizes. In the shape location module, we set the shape primitive to ring and set lower radius value. The goal will be to encompass our character's feet area. In the add velocity module, we set a small speed range with a decent minimum value to allow our particles to fly away a bit when emitted. We'll also set the origin offset on the z-axis to 0 to have our particles being pushed away from the center of the emitter's origin and not from below. In the drag module, we set the drag force value type to random range float and set a small range value to slow our particles at the end of their lifetime. We'll delete the gravity module because we won't need it here. We just want our smoke to glide on the ground. In the scale sprite size module, we'll go for a smooth linear ramp down curve template. Slightly display the left key to the right, add a new one, and set its value to 0. Then, select the key, right-click, and set the handle mode to auto. This curve will make our smoke particles quickly grow in size and shrink in a linear fashion during most of their lifetime. And we got our smoke particles done. Our smoke puff effect is looking alright at the moment, but we can make one last element to add a bit of polish and life to our effect. This is where we'll need the Shockwave component. The Shockwave component of our smoke puff effect will be using the principle of polar coordinates. We won't go too much into details here, but to simplify things, by using a flat hemisphere with default linear UV unwrap and applying a straight texture on it, the straight texture will be warped around the center point of the flat hemisphere and thus displayed as a radial texture. We are using this principle with a flat hemisphere because thanks to the subdivisions not being linearly placed on the 3D mesh, especially at the borders and center of the mesh, it will reinforce the feeling of stretching and damping of the texture when it will start at the center and when it will reach the border of the mesh. To make this component, we need a transparent shader that allows us to control the UV offset of our 3D mesh through our Niagara emitter, a hand-painted Shockwave line texture, a simple 3D mesh, and a Niagara emitter. We start by creating the new shader. This new material will be a transparent unlit one. We want to be able to control the particle's color and alpha from Niagara with the help of the particle color node, and why not use a depth fade effect. Most of all, we need to be able to control from Niagara the UV offset of our mesh to make our straight texture slide on our mesh during its lifetime. The requirements for this new shader are quite similar to the one we made back at the start of the tutorial. So we'll duplicate it and rename it. This will save us some time. After opening it, we'll focus on the part where we can control our texture offset through our Niagara emitter. We'll add two new nodes, the texture coordinate node. This node represents the UV of our mesh, and the dynamic parameter node. This node will allow us to use a parameter directly from our Niagara dynamic parameter module. This will be handy to control how our texture will slide during the lifetime of our shockwave effect by using set parameter as a curve. We want to make our texture only slide on the y-axis. For that, we'll first split off the texture coordinate node with two component mask nodes. One masking all channels but red, and the other masking all channels but green. The red channel represents the x-axis, and the green one the y-axis. We will add the red output of the dynamic parameter, which we can rename in the detail window, to the green component mask. We will then combine back both channels thanks to the append node. By linking the red component mask to the A input and the green component mask to the B input. Finally, we'll connect the append's output to the UV's input of our texture parameter. And with that done, we got our shader. We can now control directly in our Niagara emitter how we want our shockwave texture to slide on the y-axis of the UV unwrap of our mesh. We'll switch now to Photoshop to create set texture. Just like last times, I'll create a 512 by 512 document. We'll make the thread textures that will serve as our shockwave texture and will be displayed in a radial way on a flat hemisphere 3D mesh. We'll paint a simple line with a soft brush. We'll identify the head of the shockwave, the part that is the less distorted and heading towards the mesh edges, and its trail, where we'll have some fun using the finger tool to create distortion and fake some sort of directional blur. Right now, our texture might not be tileable, meaning that if placed side by side with a copy of itself, it won't be seamless. That isn't the case for tiling texture that has seamless transition between side-by-side copies. This problem will be noticeable when our texture will be applied on a flat hemisphere, resulting in a weird cut on the UV seam of our mesh. To help us make our texture tile, we will use one of Photoshop's newest tool, the Pattern Preview tool. You can enable it by going to the View panel and click on Pattern Preview. The tool will display a tiling preview of the image you are working on and update it each time you use a basic tool such as the eraser or the brush tool. When you're satisfied with your texture, you can accentuate the directionality of the texture by applying a directional blur through the use of a motion blur filter located in the filter menu in the blur submenu. And we're good to go. After you've imported your texture in Unreal Engine, don't forget to create a model instance from the UV offset model we made a minute ago, and assign our shockwave texture in it. We'll now switch to Blender to create our flat hemisphere. It will be quite simple. Create a UV sphere, cut it in half, and flatten it. Don't forget to apply the object's transformation to its data, and to rename our mesh. And that's basically it. We can export it to Unreal Engine now. And we are back in Unreal Engine to create our last emitter in our Niagara system. We want our shockwave emitter to spawn our newly created mesh once, control our texture to make it slide on said mesh during its lifetime, and make it fade away. We'll add an emitter in the system overview and select a simple sprite bust template. Just like we did with other emitters, we'll go to the emitter state and set the lifecycle mode parameter to system. We'll start by editing the visual rendering of our shockwave effect. We'll delete the sprite renderer module and replace it by a mesh renderer. In it, we'll assign our flat hemisphere mesh. We'll then tick the Enable Material Overrides parameter, add a material slot, and assign our Shockwave material we made minutes ago. Depending on the initial position of your texture, you might not see the Shockwave mesh and texture yet. We will fix this by going to the Initial Particle module and edit the lifetime, color, and mesh scale. Don't let the shockwave last too long. It will soften the smoke puff effect instead of making it more impactful. We still might not be able to see our shockwave yet. We'll need to make our shockwave line texture move on our mesh. So, we'll add the dynamic parameter module. We'll activate the first dynamic parameter, corresponding to the red output of our dynamic parameter node in our material. And since we want our texture to be offsetted during the lifetime of the shockwave effect, we won't need a simple float for our parameters type, but rather a float from curve. In the curve editor, I select a smooth frame down curve template and push the right handle of the first key down to accentuate the texture's damping at the end of the shockwave's lifetime. You might have to adjust the value of your keys due to the initial position of the straight line texture compared to the UV unwrap of your 3D mesh. Alright, now our shockwave is visible and animated. We just need to make few adjustments. You can go to the Scale Color module and play around with the curve to hold a bit the opacity of the shockwave and make it fade away quickly before even the real end of its lifetime. To avoid our shockwave mesh to be spawned at ground level, we'll add a shape location module, set the sphere radius value to 0, set the offset mode to default, and set a small value in the z-axis to spawn our mesh above ground level. The effect is mostly done. Good job, everyone! Don't forget to rename your emitters and we're good to go. You might need to adjust some parameters in all emitters after seeing it in action. Speaking of that, we see right now how to spawn our effect each time our character is playing its landing animation. The character used here is the default mannequin available in Unreal Engine 5. I find its landing animation in my content browser and double-click on it. We can see the default mannequin playing over and over again its landing animation. To spawn my Niagara system at a specific frame of its landing animation, I place my cursor on the desired animations frame, right-click on the cursor in the track number 1, add Notify State, and select Timed Niagara Effect. I click on the N key of the Notify State and slide it enough to let enough time for the effect to entirely play before being killed. After selecting the Notify State, I'll be able to assign my Niagara emitter and attach it to a bone. In my case, I'll attach it to the root, at the feet of a character. And now, we should be able to see our smoke puff effects being spawned each time our character is playing its landing animation. To watch it directly in-game, hit the play button in the editor, and jump around by pressing the spacebar. You can now take some time to tweak some of your FX values, such as particle sizes, shape locations radius, or number of particles being emitted, to better fit our character's scale and its jump height. And that concludes this video. I hope you like this tutorial, and I see you in the next one. Bye!